Okay, this is the video lesson for Algebra 2, 9.4 Arithmetic Series. So we talked about arithmetic sequences already, 2 sections ago, and now we're moving on to series. So in this lesson, we're going to define arithmetic series and then find their sums. So series is just the sum of a sequence, or the terms of a sequence. A finite series, like a finite sequence has a first term and then a last term, so it ends, it's finite. An infinite series continues to go on without end. So the sum of a finite sequence, this is a finite sequence, the series of that is the sum of the terms, right? 6 plus 9 plus 12 plus 15 plus 18 here. So the sum here is 60. An infinite sequence, right, would just go on. That's what these ... mean. An infinite series would just go on as well, or a series. So an arithmetic series is a series whose terms form an arithmetic sequence. These are arithmetic sequences here. And when a series has a finite number of terms, you can use a formula to involving the first and the last term to evaluate the sum. So that formula is given here. The sum of a finite arithmetic series. So you can take the first term and add it to the last term, multiply it by the number of terms, and divide it by 2. And that is the sum of a finite arithmetic series. So let's see that in action with problem 1. What is the sum of each finite arithmetic series? So the sum here is number of terms divided by 2 times the first term plus the last term. So the first thing you can see that we need is to figure out what this n is. Right? We have the first term and the last term, but how many terms do we have here? This is a little bit easier because it's just all the even numbers up to 100, so there's going to be 50 of those. But if we didn't know that, what we would do is use we know it's an arithmetic series, right, or an arithmetic sequence, right, where we add 2 each time. So our d equals 2, and we can use our explicit formula for our arithmetic sequence, right, to do our last term. So our last term is 100. We know that that's the first term plus whatever number term that is minus 1 times d, which is 2. So we can figure out what number that is here by solving for n. So we can subtract 2 from both sides. We get 98 equals, and let's distribute this, 2n minus 2. Oh, then we add 2. Guess we didn't have to do that. 100 equals 2n, so n is 50. Okay, so we figured out what n was. So this is s of 50 is 50 divided by 2 times the first term, which is 2 plus the last term. So this is 25 times 102. And luckily this time I have my calculator, although we could figure that out, right? 25 times 100. 25 times 2 is 50, and 25 times 100 is, right, we can actually, this is what I'm doing. Right, 2500 plus 50 is 2550. We didn't need a calculator. Okay, but you can use a calculator, and I have one this time. So let's do the second one similarly. It's not as easy to figure out 50. Some of you could have just figured out that n was 50 without doing all this. But we're going to have to do all that for this. So let's find our d. 11 minus 7 is 4. And let's just double check that. 15 minus 11, also 4. So d is 4. Our last term is 223. That's going to be 7 plus whatever n is, which we need to find, minus 1 times 4. So let's distribute that 4. We get 223 equals 7 plus 4n minus 4. Which is 223 equals 7 minus 4 is 3 plus 4n. Let's subtract that 3 from both sides. So 220 equals 4n. Divide both sides by 4. And you get 55. So n is 55. So now that we have our n, we can do this formula here. So I'm running out of room. S of 55 equals my 55 divided by 2 times my first term is 7 plus my last term is 223. And we can do that in a calculator. 7 plus, well, we don't have to do 7 plus 223. That is 230. 230 divided by 2 is 115. All right, we can do that on a calculator. 115 times 55 is 6,325. So if we added up all these numbers following this pattern, or all these numbers in this sequence, this is what we would get at the end. Okay, so try that one on your own. Try C on your own. I don't know if there's a D. I haven't looked at the next page yet, but try C on your own. So this is actually all odd numbers up to 200. So figure out what your n is, and then use it to plug into the formula for the sum of a finite series. Push pause and check back for the solution. Okay. Hopefully you got 2,500. N was again 50. This is all odd numbers up to 100. And then you plug them in. You can actually think about what this number means, right? Every single one of these numbers in this sequence is one more than that one. And since this was, and there's 50 numbers, so this basically is just this minus 50, which is 2,500. And you didn't need to know that to solve it, just showing you as an extra check. Okay, next page. Yes, there was another one for you to try. Okay, so try this one. Press pause, figure out what your n is, then figure out what your sum is. Check back for the solution. All right, hopefully you got 1863. You can see that n is 27 because the d is 5 and our last term is 134 and our first term is 4. So we found that n is 27, plugged it into our formula for first term plus last term divided by 2 is 1863. Okay, so let's move on to a word problem. When is this used? Well, we use in a problem like this. A company pays $10,000 bonus to salespeople at the end of their first 50 weeks. If they make 10 sales in their first week and then improve their sales number by 2 each week after. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did the salesperson make in week 50? And then again in all 50 weeks. So let's look at this here. So they make a bonus at the end of their first 50 weeks if they make 10 sales in their first week. So the first week they make 10 sales and then improve their sales by 2 each week, right? That means the next week it's 12, next week it's 14, and this pattern continues for 50 weeks all the way until, right, so this is n equals 50. And so we can get to, we also need the last term, don't we? We can actually figure out what the last term is because we want the 50th term. Instead of adding them up every time, we can do what's our 50th term? It's going to be our first term plus our 50, n minus 1. And then this is 2, right? Because it goes up by 2 each time, times 2. So this is 10 plus 49 times 2, which is 98 plus 10 is 108. So that is what the first question is asking. How many sales did the person make in week 50? So the last one. So this is 108 in week 50. And then we need that to solve for how many sales did they make in all 50 weeks. So we would just be adding these all up. Right, so this is my S of 50. So S50 equals 50 divided by 2 times the first term plus the last term, which is 25 times 118, which is 2,950 sales in total for 50 weeks. Seems like a lot. In 1 week he makes 108 sales, and the first week he makes 10. Guess it depends on what you're selling. All right, moving on. So this is going to be called series notation. So this is, if we have this series here that starts 3 squared plus 4 squared plus 5 squared plus blah, 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 all the way to 108 squared, you can actually write this in a series notation. So this big weird looking E thing is a Greek S, so that means for sum. That's what that is. And then you're gonna, this n equals number, this is the number you're gonna start with, and this is the number you're going to end with. So this is the lower limit. This is saying the series is going to begin with n equaling 3, right? Because that's the number you're plugging in. It's basically the number that's changing each time. This is that's going to be your n. Whatever number changes by 1 each time. So that's what that, and that's their explicit formula. And then the square doesn't change. And then so you start with n is 3 and you end when n is 108. So this would be n equals 3 to 108 and then n squared. Okay, so that is series notation. Problem 3 is asking, what's the sum, or we're calling it summation notation. I like calling it series notation, but let's call it summation notation for this series here. So what we want to see is, right, what kind of series is this? So this looks like, since we're in the section called arithmetic series, we're going to check that first. 11 minus 7 is 4. We had the same series already. This is 4. You can also see that that's plus 4. So my D is 4. And that means my explicit formula, a to the n, equals my first term plus n minus 1 times 4. Right? Remember this? We just used it this whole section. I actually didn't write it down again. This is our explicit formula for arithmetic series or sequences. Okay, so this is my explicit formula. So our summation notation is we're going to have the sum of, and then to get 7, you would have to plug in 1 here, right? Because this is my first term. So if we plugged in 1, a1, 7 plus 0 is 7. So our first term, that's when we plug in n equals 1. So we're starting with n equals 1. And then what do we have to plug in to get the 207? Well, let's see. 207 equals 7 plus n minus 1 times 4. 4n minus 4 is 4n plus 3, right? This equals 3. So we're going to subtract 3, 204, and then divide by 4. This is 51. Yeah, so we're going to stop at 51. So we start when n equals 1, we stop when n equals 51, and our explicit formula is this guy, 7 plus n minus 1, 4. Let's just clean this up a little bit though. 4. This becomes 7 plus 4n minus 4, and then 7 minus 4 is 3, so 4n plus 3. Actually got that there, so this is 4n plus 3. So this is our summation notation for this series. So we figured out the explicit formula, last n, first n. Okay, that means you're going to plug in. What this means is first you plug in 1, then you plug in 2, then you plug in 3, and then you add them. That's what this is saying. Add every time you plug in a new n, and then stop there. So that's what that's saying. Okay, so you have 2 to try on your own, and then you'll be done. So try this first one, and then we'll check back for the solution, and then you can try the second. Press pause. Okay, hopefully you got that n starts at 1, ends at 40, and the explicit formula is 7n minus 12. Right, we started with a equaling -5, and then if you plug it into our explicit formula for arithmetic sequences, right, we found that D was 7 by subtracting these terms. 2 plus 5 is 7, 9 minus 2 is 7. So then you just plug in the 7, your first term is -5, and our last term is 268. I distributed the 7, and then before I solved this was my explicit formula. And then I solved that for what is my n when I get my last term, which is 268, which is when n is 40. So that's what this 40 came from. So hopefully that's what you got. And try your next one. Press pause. Check back for the solution. Okay, hopefully you got your explicit formula as -10n plus 510. That's when you plug in your first term and your D into this formula here and simplify here, and then set that equal to 10, your last term, to find out what the n was, and that's 50. Plug that in there. Okay, here is your practice for this section. Please email me if you have any questions. Enjoy.